Welcome back. We're going to talk about the microscopic explanation of forces in general, like contact force and other things, but specifically we're going to talk about in regards to fluids because AP cares a lot about what causes these forces, particularly in the buoyancy subtopic. There's not as many questions about buoyancy so much as what is the explanation behind buoyancy, which I think is a little odd, but that's AP. So there's four fundamental forces in the universe. And by fundamental forces, we mean like these are the only forces that exist. Every other force that you encounter is a different expression of these forces. I started to write the word encounter instead of electromagnetism. But those four forces are first, gravitation, which does gravity things that you're familiar with. It holds you to the planet, it holds the Earth to the sun, holds the moon to the Earth, and causes orbits, galaxies, stars, supernovas, black holes are all very related to the gravity. Supernovas, there's I guess a lot of electromagnetism involved too, and nuclear stuff. I guess supernovas are very complicated. The next one is electromagnetism, which is responsible for attraction and repulsion of charges, as well as many other things. Light is in there too. Then the third one is the weak nuclear force, which the weak nuclear force is probably the least understood of the four, at least by people who are not nuclear and particle physicists, because most people have a hard time explaining it, but the fundamental thing it does is that you can experience certain types of nuclear decay are the direct result of the weak nuclear force. So it's kind of a very specific one, and you're not going to see it all that commonly, and you certainly won't be able to know you're experiencing it. And the last of the four is the strong nuclear force. Now, the strong nuclear force is responsible for holding protons and neutrons together in the nucleus of the atom, and is also responsible for holding the quarks together inside of the protons and the neutrons. So those are the four main things. So what I want to know, and you can pause it and think about this for a minute if you want, is which force is responsible for touching things? Like, say hi to Cicero. But which force is responsible for you being able to touch things? When you put your hand on the table and push down, there's a force there. And I said that these are the only four forces that exist in the universe. So which of them does that? So let's think about this. Let's start gravitation. Could it be gravitation? No, it can't be gravitation for a couple reasons. Well, because gravitation is the weakest of the four forces. So but you experience it pretty strongly in your life. But also, gravitation is only an attractive force. And when I push down on the table, it's repelling me, right? It's pushing me away. So it can't be gravitation. Another option would be the weak nuclear force, right? But like I said, the weak nuclear force is only responsible for certain types of particle decay and nuclear decay. So it's not going to be that one. And the strong nuclear force is a very short-range force, and it's only responsible, not only, but it's primarily responsible for holding the nucleus together and holding protons and neutrons together. So it's not that one either, which means that the only one left is electromagnetism. That is the touching force. That is the force responsible for allowing you to touch things and for allowing you to interact with things, pick things up. It is also, so aside from gravitation, there's no force that you experience in your daily life that with direct relation to that. There's nothing that you experience besides gravity that has its answer anywhere other than electromagnetism and quantum electrodynamics. That is a very important subject in physics, and it's a very powerful thing, and it has very much a lot of control over how we live our lives. So how does this relate to the fluids and buoyancy, though? Well, if we're talking about buoyancy and drag forces, they'll often ask about which microscopic interaction is responsible for it, and they have quite a lot of questions like, oh, is it the nuclei pushing at each other? Is it the a nucleus pulling on an electron? Is it some other force entirely? I don't even know sometimes, but it's always electromagnetism, and the answer for how both of these forces work is going to be you. In your atom, you've got your tiny little nucleus in the center, which is very small compared to the size of the atom, so this drawing is not to scale. And then you've got your electron orbiting that. So I'm kind of drawing this in the Bohr model, which is not the best. And you've got your electron. So you've got a couple electrons in here. This drawing is amazing for you art lovers out there. And when you bring it near another atom, right, those electrons are going to kind of push off of each other because they experience a force from each other because they're negatively charged, and so they're going to repel. And that force is responsible for drag force, it's responsible for buoyancy, it's responsible for so much. So the electromagnetic force is going to be a kind of just look for things that look like that, and look for things that are looking at the intermolecular forces, I guess is a good way of thinking about it. Because the nuclear forces are responsible for a lot of forces inside of the atom. And the force of the nucleus on the electrons is a lot about the forces inside the atom. But if you want to know about things that go on outside the atom and how atoms interact with each other, that's almost always just the electrons. So look for those answers when you're doing those questions. I think it's going to get you very far considering it that way. All right, guys. I hope this one was helpful. So just stay safe out there, make good decisions, practice good social distancing. All right. I will see you in the next video.